In this question, we're asked, which is the better solvent for some given solutes? And to answer this, we want to remember the chemist's rule of thumb. Like dissolves like. And what's alike is intermolecular forces. So this means that polar solvents dissolve polar and ionic solutes. And the example I'm going to go over, there are no ionic solutes, but on some other ones I saw, there were. So these polar solvents dissolve these polar and ionic solutes. Nonpolar solvents dissolve nonpolar solutes. So like dissolves like is really about intermolecular forces or polarity. So in the first case, we have hexane as the solute. So it's 6-carbon chain. You don't need to know that it's called hexane, but it only contains hydrogen and carbon. So it is non-polar. So first, we want to identify whether the solute we're trying to dissolve is polar or nonpolar. Well, this particular solute is nonpolar. Water is very polar. So this is a very common solvent, so we know this is polar. Carbon tetrachloride, where you have all 4 domains being chlorine, is actually nonpolar because all domains are the same. So carbon tetrachloride is a nonpolar solvent. So the nonpolar carbon tetrachloride will dissolve the nonpolar solute. In the next example, we have benzene. This is called benzene. Again, you don't need to know the name, but you do notice that it only contains carbon and hydrogen. Molecules that are only contain carbon and hydrogen, like these organic molecules, are non-polar. So again, we want to identify the polarity of the solute. This one is non-polar. Here we have a solvent with only carbon and hydrogen, also nonpolar, or water, which is very polar. So we're going to choose the hydrocarbon solvent, which is, again, hexane, the same one that was over here, as the solute. In the next example, we have urea. Urea is polar, okay, and in fact it's capable of hydrogen bonding from these NHs. It's polar because of this carbonyl group, the C double bond O. So not all domains are the same. This is polar. So our choices are this only carbon and hydrogen containing solvent, which is pentane, which is nonpolar, or this molecule, which is technically a solid at room temperature, so but at elevated temperature, theoretically you could melt it. This isn't technically a solvent, but you'll notice here that it has what's called a carboxylic acid group, which is a C double bond O, which is polar, and even an OH, which is capable of hydrogen bonding. So this molecule, benzoic acid, is polar. This molecule, urea, is polar. So your better solvent is this one for the polar solute. I have a few more examples here. Here is a bit of a tricky example. Here we have ethylene glycol. This is definitely polar. All right, it has an OH here capable of hydrogen bonding and an OH here capable of hydrogen bonding. This is found in things like antifreeze. Here we have a ketone, so we have this C double bond O, which makes this polar, but then we have ethanol, common drinking alcohol, which has an OH. So since this, I guess, can more effectively hydrogen bond with this, it's probably the better solvent choice. However, it's probably also soluble in this one. But this is probably the better answer because it has the OH, like this has an OH, and what it asks for ultimately is the better solvent. So this is arguably a better solvent because it's more alike with this one. Remember, like dissolves like. This example we already had. We have hexane, which is non-polar, and it's not going to dissolve in polar water. It's going to dissolve in the non-polar carbon tetrachloride. The last example. In the last example, we have this double carboxylic acid on both ends, and so it has this OH. You'll notice that we have ethanol again, which has an OH, which is very alike, so that's good. And here we have an interesting compound with this S double bond O. Note that S is only slightly lower on the periodic table, so it has a lower electronegativity, but a similar electronegativity to oxygen. This molecule is somewhat polar. It's not as polar as if this were, for example, a C double bond O, but it is somewhat polar. However, we have an OH here, an OH here, so this molecule is the better choice. Again, I forgot to write it down. This is a polar molecule. Has this what is called carboxylic acid functional group, but you notice the C double bond O and the OH are what makes that polar. So this polar molecule dissolves in this polar solvent. Another way of thinking about it is this has an OH and this has an OH, so therefore they're more alike, so therefore it's a better solvent.